All right, so then, then let's start. Welcome everybody, and thank you for coming. My name is Arif. I'm working as a consultant and developer for ThoughtWorks. But the last about 18 months, I've been working with these nice guys from AutoScout. And this high-performance solution to microservice UI composition that we're going to present to you today was developed during that time in a joint team of ThoughtWorkers and AutoScouties.
Hello, guys. My name is Alexey. I'm working as software developer at AutoScout 24. Before we go into topic of UI composition, I'd like to give you some background about our company, our motivation, why we are doing it, and some context in which we developed our solution to UI composition. In Norway, AutoScout probably not that known. Does anybody know AutoScout from here? Oh, okay, a couple of you. So for everybody else, AutoScout is a marketplace for new cars and used cars and motorbikes and stuff like that. We are present in 17 countries. In some countries we have full presence, like full-featured marketplace, where we are having contracts with our dealers and stuff like that. And in other countries we have just a translated version of our search funnel. On our platform we have about 2.4 million of cars and motorcycles, and our platform serves about 3 billion page impressions. Yeah, not hits, but real page impressions per month. Exactly. About 1.5 years ago, we started a project that we call Tatsu. Yeah, just because every big project have to have a name. Tatsu means dragon. You see that logo on the background. And it's a dragon because project is more or less rewrite of complete platform of AutoScout. So we compare it in our minds with dangerous but quite powerful dragon. Yeah. In this project, we are doing 5 things at the same time. First of all, we are breaking old and rather monolithic system into a bunch of self-contained microservices. We call them vertical slices because they having everything they need inside of them, from database to UI, and that's actually why we are talking about UI composition today. We're also moving from self-hosted data center in the cloud, well, not in Azure, but in AWS. And because it's more or less building all the stuff from scratch on a green field, I wouldn't call it migration. We just selected not .NET platform, but Linux and JVM platform to build it from the beginning. Just because it's not enough for us, we also doing some internal changes in our internal structure. So we are changing structure from having separate operations department and development teams to full-featured teams where operations people are members of every team, and teams having knowledge to build and run their stuff on you build it, you run it approach. That means team is responsible to build stuff, to test stuff, to deploy stuff, and if something breaks in the 4 o'clock in the night, well, to fix stuff. Yeah, and just because otherwise it will be too boring for us, it's also so-called shiny new card. So our platform is a couple of years, actually more than 10 years old, and over the last years there are some features which were built at some point of time, but are not either not used by majority of our customers or not used at all. So we are thinking what features do we really need, and cutting everything else out. And yeah, that's what shiny new cut means. This whole project obviously is a huge effort, so why we are doing it? One of my main reasons for that stuff is to reduce time to market, so we can respond to needs of our users more quickly. For this, it's really important that we can release new features very quickly. Also, having possibility to test A/B, doing A/B testing of some features and get early user feedback. So the idea of that is to having possibility to release stuff within minutes, not days and not even hours. And we believe to do that, our teams should be enabled to be able to innovate independently. We believe that the key to achieve this autonomous team, that means they should be able to work independently on their services. Therefore, we believe that it's crucial to avoid any form of any tight coupling as much as possible. So if team wants to improve their stuff, but they have to wait for other teams until they will be able to release their services or their features, it's not real team autonomy. So in fact, we value team autonomy that much that we also accept certain trade-offs. Like in some cases, we would rather copy code around than introduce a shared library, which will be used by multiple services. At the same time, we don't want to compromise page speed. Does anybody of you knows what page speed insights is? No? Oh, just a couple of you. So page speed insights is a tool built by Google that analyzes the structure of a page in terms of how fast page could be rendered, particularly on mobile browsers. And score of page speed goes up to 100, and good score is considered starting from 85. We also strive for low latency. It's obvious that pages should be rendered and served fast. That means that we heavily rely on different cache layers and that our pages shouldn't have any blocking content. In context of microservices, it's actually a bit tricky to achieve both high page speed and team autonomy.
All right, thanks, Alexey. So now, in order to explain why it is actually so hard to combine a good page performance with good team autonomy, I'm now going to present to you two different ways how to generally approach this problem. And the first of the two ways is the API gateway pattern. Does anybody of you know the API gateway pattern? All right, so let's take the autoscout24.com page as an example here. Actually, the German page is much more complex, but I think this .com page here serves as a good, simple example. So you can see that, it consists of a main content, and then there's a header and a footer. I mean, that's not a very surprising structure of a web page. So if we approach this now with a API gateway pattern, then this could look like this. So here you see that in the backend, the monolith is already broken down into several independent services, such as the homepage service here or the header and footer service. And now, for example, this red UI component here could represent this main part of the homepage, which is content which comes from, or which presents content which comes from the homepage service, whereas you could imagine this orange part here as the footer, which presents some content which comes from the header and footer service. So now you see in the backend, it's broken down into services, different or independent services. But in the front end, you see that it's still one big web application, which takes care of the whole web UI. And now, in order to avoid that just when performing a single action, the web application has to start several requests to several different backend services, it's generally a good idea to introduce such an API gateway here in between, which aggregates requests and thereby dramatically reduces the number of requests that is required for a single action, which is particularly important when you view the page on a mobile device. So this is generally the idea, or one of the main ideas of the API gateway pattern. So it's actually great for page performance because you have this request aggregation and also this single web application. It's fairly easy to optimize for good page loading times because you have all in one application. You can optimize it all together and thereby get good page performance. However, there are quite some drawbacks to this API gateway pattern. And the main drawback here for us is that that truly independent feature releases are not possible, at least not if those feature releases include something being changed in the backend and in the front end. So let's say something needs to, just something in the footer needs to be changed. So there is some change in the header and footer service and something visually needs to be changed in the web UI. Then in the worst case, 3 teams have to be coordinated to just make this single change. The web application team, or the team that takes care of this web application, the team that takes care of the API gateway, and the team that is responsible for the header and footer service. So this is no truly independent feature release, and that is because we basically just went halfway here of breaking down the monolith, because we only broke it down in the backend, but we still have kind of a UI monolith. So to sum it up, this approach is good for page performance, but it's rather bad for team autonomy. And now, because we actually do this whole effort of rewriting the Auto-Scout site to get more team autonomy and get faster, or faster in releasing new features, this drawback really rendered this API gateway pattern no option for us, at least not for the web page. So instead, we went for another pattern, and this is now the second pattern I'm presenting, which is the UI composition pattern. So the same thing now with this pattern would look like that. So again, imagine the Auto-Scout page, and now in this example here, the homepage service would contain the backend logic for the homepage service, but would as well deliver the actual HTML, JavaScript, and style sheets. And similarly, the header and footer service would contain the backend logic and would also deliver the HTML, the JavaScript, and the CSS, which is required for that footer piece of the Auto-Scout page. And because, that's the reason why we call those services vertical slices. Alexey already mentioned it, because with this pattern, basically each service contains a front-end part, a back-end part, and everything in between. So there is no classical layered architecture anymore. This way, each team can basically change their backend and their UI at the same time, pretty much independently. Of course, just as long as it doesn't affect other parts of the page. But if it doesn't, they can really completely independently release their change and do not have to coordinate with anybody else. So this UI composition pattern approach is really great for team autonomy. However, there are quite a few challenges that come with that approach. So first of all those pieces of the page that come from different backend services or different services have to be combined into one single HTML page in the end, because that's what is delivered to the user. Furthermore, we must enable each service to deliver not only the HTML, but also the style sheets and the JavaScript at the same time. Then the page structure must not break, or the final page structure must not break the page performance. And that is actually already getting tricky, because any single service that is part or that delivers some content which is displayed on the page in the end could introduce some render blocking content and thereby basically pull down the page performance of the whole page. And the same goes for the request latency, because of course the latency is determined by the slowest of all services that are involved. So generally you could say, whereas team autonomy is really good with that approach, achieving good page performance is a bit tricky here. And then finally, also independent testing of those UI components, and also testing them with integration is a challenge with that approach. Now, in order to illustrate you how much of a challenge such a high-performance UI composition is, I'm going to quickly tell you the story of our first, well, not particularly successful approach to solve this problem. And that approach was based on Varnish and ESI. Who of you knows what Varnish is? All right, quite a few. So Varnish is an HTTP proxy cache. You can also call it an HTTP accelerator. And who of you knows what ESI is? Okay, not that many. So ESI means edge side includes. And an ESI tag is basically an HTML element which can then be replaced with some content which could come from another service. Let's see how this looked in our particular environment, which was or is AWS based. So you see here there is an instance of this Varnish proxy cache, and there is an elastic load balancer ELB in front of Varnish, and then we have those upstream services, how they are called in this terminology, and there is a ELB in front of each of those services. Now, if a request from a browser hits or is now requesting the home page, then this would hit the Varnish. Varnish would route this to the homepage service. The homepage service would deliver an HTML page which contains some ESI tags. For instance, an ESI tag saying, here comes the footer. And then Varnish would go back to the footer service, retrieve the content of the footer service, replace this in here, and delivers this back to the client. So let's have a look how this looks in code. So this, would be a really dumbed down example of how the content could look like from the homepage service. So you see this is a normal HTML page with HTML tags around it. And then you see up here the head section with already minified style sheets, and down here you see also JavaScript, which is already minified, and here you see there is the ESI tag, which simply says ESI include, and then you see here the source routes to the German header. So now this gets replaced by Varnish, and then you see this is the content which is delivered by the footer service. No, it was the header actually. So this is the header. And you see now there is the style sheet of the header, the actual content of the header, and the JavaScript of the header. Now, the problem of this page structure as this is that the page speed would be really bad, or is really bad, because we have now render blocking style sheet links and JavaScript scattered all over the place, or all over the page. So yeah, from the page speed insight score would be really bad. Okay, so then we thought, how can we improve this? And an idea that we had was to split up this include into, or getting the content from the different services into multiple ESI includes. So basically include the content at 3 places. First here, one include for the styles, and that is already in the head section here, and one include for the actual content, and then another include for the JavaScript. So in this case, if this now gets replaced, we have a good structure, so the page speed would be much better that way. However, we now have another problem, and that is really tricky as well. So, and that is asset version inconsistency, or possible version inconsistency. So imagine now we would release a new version of the header, and this new version of the header would come with some new HTML content and also some new style sheets. Now, of course, because we want to provide good page performance, we're caching everything, right? And especially Varnish is a cache, so we're actually caching those responses from the upstream services. So now those different things here could have different times to live, or basically the cache could be invalidated at different times. So that means it could happen that we already get the new content, the new HTML content, but the cache is not invalidated yet for the style sheet, so we still get the old style sheet, and therefore we have inconsistencies here. So, and right away we actually did not see, with this approach of separate ESI includes, we did not see a way to solve this. So this was a huge problem here. Also, another thing is that the assets are not combined yet, but that's even a minor issue in comparison to the version inconsistency, because this may not be so much of an issue if you only release once a month or whatever, but as we release several times per day, yeah, this situation is much more likely to come up. Yeah, so basically what was the situation at that point? We had our team had the job to build a solution for the UI composition of the new AutoScout page. And with the first attempt with Varnish and ESI, we had either a bad page performance because of a bad page structure, and then attempts to optimize the page structure led into an increased complexity regarding the asset handling. Furthermore, this approach with having multiple ESI includes puts a high burden on the teams actually providing this content, because they have to provide 3 different endpoints for the different things. And also combining assets with ESI is possible, but also adds more complexity. And then above all those issues, We had a specific issue, an issue specific to our environment there, because we are using AWS elastic load balancers. So an elastic load balancer actually consists of multiple IP addresses because of the multiple availability zones. But now Varnish actually says, as an upstream service, I want one IP address, otherwise I'm not going to start to work. So that was basically then the killer issue that we could not go down that way. So yeah, we kind of had a bad week. Yeah, we had a lot of problems. But at least we knew by now what were the requirements for a better solution. So we knew that the solution that we needed to provide, in this solution it would need to be possible for the upstream services to provide the links to the assets and so on as part of the HTML itself, so that we do not have those version inconsistencies. And at the same time, in order to get a good page performance, this means that we need a solution with some post-processing. Furthermore, we wanted to have some support for combine assets to get a better page performance, and also inlining CSS and JavaScript would be nice. And finally, it would be nice to have support for shared cache between instances. Because we're using immutable servers, and therefore, yeah, it would be really nice not to kill the cache with every release, right? Yeah, so that were the requirements that we came out of this first failed attempt to solve the problem. And now Alexey is going to tell you what solution we then came up with.
Yeah. So we finally found a right solution that satisfied all our requirements. And at the end, our solution consists of three main parts. So it's at first it's Nginx with SSI module to resolve include. So it's basically SSI module is very similar to what ESI functionality in Varnish is doing. Second part of it is a page speed module for Nginx, which is developed by Google and which is doing post-processing, post-optimization for composite pages. And third part is AWS Elastic Cache, which is nothing more than memcached. It was basically externalized cache. So our services were completely stateless, and in Azure world there will be Windows Azure caching, something like that, which acts exactly like memcached. Yeah. So let's check how request flow works. So when request is coming from browser to Nginx, Nginx resolves from configuration that for this path is some service responsible and sends request to a service. Service returns page with SSI includes, which gets parsed, and Nginx and SSI module resolves all SSI fragments on the page and loads them from different upstream services. Afterwards, page is given to Nginx page speed module, which is doing post-processing. In particular, it prefetches all assets, all styles, all JavaScripts, combines them, and generates a single link out of it, places JavaScript just below the page and all styles in the header, and yeah. And in addition to that, we have two-level cache, but we'll talk about this in a minute. and afterwards, post-processed page sent back to browser. And as we found at the end, it worked much better than our first attempt with Varnish.
All right, so now before showing again how this all looks in code, I just want to explain that we conceptually distinguish between what we call a page and what we call a fragment. So pages are generally publicly accessible via URL, whereas a fragment really is just a part of a page. So pages get called from the client, so the browser, whereas fragments really just get called from Nginx's SSI module in this case. A page can include fragments, obviously, but also fragments can include fragments. So we can nest fragments, but of course a fragment cannot include a page. Then a page could be cacheable. However, there could be various reasons why a page could not be cached, such as cookies or so. A fragment, on the other hand, should really be cacheable. So the idea is that a fragment is a rather static thing, a static small thing that can be cached easily. And then finally, pages define contracts for fragments, and fragments have the job to adhere to those contracts. So they have to behave well as part of the page, for instance, not consuming more space on the page than they're allowed to. So now let's have a look again on a simple HTML page here coming from the homepage service again. You see now this looks very similar as in the ESI approach. So again, you see here the minified and actually already combined style sheets, and down here the JavaScript. And here this is now the SSI include. In contrast to ESI tags, SSI includes are basically just HTML comments, which then say #include virtual, and then again you see there's the the path to the German header in this case. So this gets then replaced by Nginx's SSI module, and again you see here that this is the content that comes back from the header service here, and you already see the content that it gets delivered by the header service has a nice normal structure. It has a head section with the style sheets in there, then the actual content, and then as you would do it normally at the end there's the script section. So from the perspective of the team that is delivering that content, that fragment or the content of this fragment is relatively easy to test, also to display in isolation and so on. Of course, now we have the same issue as before. The page performance of this page as it is would be really bad. So therefore now the Nginx page speed module or mod page speed comes into play. And this mod page speed provides several filters. And one of those filters is combine heads. And basically those filters are post-processing steps. And so now going back here, you see there is a head section here in the content that has been delivered by the header service, and there is a head section here. And then the combine heads filter would do what you would assume that it does, and thereby basically pulling up this style sheet link up here into the head section. So this already improves the page speed, but it's not that great yet. And then there's the next filter that we apply, which is combine CSS and JavaScript. And this filter now really combines all those style sheet links up here, and also it combines all the JavaScript down here. So now really we have a really good page structure with a good page speed. And in here, the only thing that is left is the actual content, or left untouched is the actual content that came from the header service. So actually with those more or less with those two filters, there are many more filters of mod page speed, we were able to get a really good page speed score. So of this small page that we developed that uses this UI composition, we were able to get a score of 97 for desktop and even 96 for mobile. So those are actually really great numbers. Although I have to warn you, if you go to that page or the AutoScout page right now, it will actually show lower numbers because we have ongoing discussions whether we want to load the font synchronously or asynchronously. And because right now the decision was to load it synchronously, the page speed is rather bad, which is an example of how one page or one fragment being able to pull down the whole page speed of the whole page. But generally, apart from that, the page speed that can be achieved is really great. So yeah, now Alexey is going to tell you something about caching.
Yeah, right. Let's talk about caching. Small recap of how the whole stuff is working. So request is going to Nginx, SSI module, page is loaded, fragments resolved, page is parsed by page speed module, and then all assets are prefetched. And let's check how one of our two cache levels and why is working. So first of all, we have a so-called proxy cache, which is sits at the lowest level of request processing pipeline, and it caches actually responses from upstream services. This adds as additional level of resilience. That means if some service will go down, yeah, we will be able to get content out of cache. Well, better stale content than no content at all, right? Second, cache headers from upstream services are always respected. So we think that teams know how to cache, how their stuff should be cached. So we are not forcing them to do anything here. We also support cache key modifications via very header. I will talk about this in one of the next slides. And the whole stuff is externalized in AWS Elastic cache, which is nothing less than memcached. Memcached could not be attached directly to Nginx. Nginx can read out of it, but not write into it. So we enabled it by using Nginx cache module, SRC cache module. Yeah. Second level of cache is cache for post-processed and optimized pages and assets. That means that all generated assets, which are already combined and minified and stuff like that, are stored there. Again, it's same Elastic cache, which basically enables us to throw away servers. So our servers are completely stateless. Yeah. It also allows us to do a rolling update without having any cache synchronization. And the cool thing about it, we never have cold cache. And since cache is completely externalized, this solution is scaling horizontally to almost unlimited number of instances serving all requests. Well, of course, limitation of memcached still applies, but yeah, it also can be scaled horizontally pretty good. So how caching of assets working here? All our assets pictures and styles and JavaScripts are fingerprinted. That means that during compilation, there are hashes generated out of content of files and hashes added to file name. That means if you do some modification to those files, you will always get a new file name. That means every single version is has unique file name. That means we can cache it for like forever. Yeah? Well, forever probably not good idea because sometimes your cache will be filled, and so we said let's cache it for 1 year. And this thing is controlled by our microservices serving assets, and our UI composition layer is just respecting all cache headers coming out of upstream services. Second level of cache, which is basically sitting on near page speed module, is caching all combined assets. When Arif was talking about processing page, he said that all assets are prefetched, combined, and there is one single link generated out of it, where all assets are just put together. And just to not burn CPU every time when, because processing costs CPU. Just to not burn CPU every time page is served, we are caching calculated versions of our assets. Okay, let's check how caching of documents is working. So it's more or less the same. Cache of proxy module still respects all cache headers coming out of upstream services. The only difference is that at this point you have only one level of cache because, there is nothing to combine. So pages basically get served from services, and it's not getting minified or combined or something like that. There is possibility to control cache behavior by adding a vary header. Why we do need this? On the front, from outside, our website is visible on 17 different domains, right? And having all 17 different domains for all services, upstream services, which are serving content, is quite overhead. So we decided to keep one single domain for upstream services, but we still need to cache somehow different version of content because of different languages, right? And our proxy module is transforming, what it's doing is transforming cookie where user stores his language settings into a, you see here, header X cookie culture, taking value out of culture cookie and sending this header to underlying services to while retrieving fragments, because otherwise underlying services cannot see underlying services serving fragments cannot see original requests. They are so-called sub-requests in Nginx. So only page request sees original requests, and fragments just don't see it. This way, we enabling services to say if you have some content based on language. It's also possible to evaluate language by transforming cookie into header variable, and service can say, my stuff should be cached based on this cookie, and then value of based on this header, and this value of this header is added to cache key afterwards. Okay, testing. When you're developing your stuff, of course, it's a good idea to test it. Releasing stuff untested doesn't work that well. But how to test your single service which you runs on your machine if everything else served from, I don't know, from maybe 10 services or 20 different services? And let's check how it's working. It's already, you should already know this page is our international homepage, having 3 fragments: header, footer, and main area, which comes out of homepage service. And let's say we want to change it and test header locally. So you have your developer machine where you develop your header, and you want to check how it fits into the page and plays, if it plays nicely together with other parts of the page. So we built a Docker container, which is basically same jigsaw, configured same way with only difference that caching is completely disabled there. All other parts of functionality are absolutely the same. And it's possible to say to this Docker container, please take my service from my local machine, while all other services will be still taken out of the cloud. So this way, Nginx combines content delivered by your local service from your local machine, while everything else is, get out of production, basically. When teams started using this solution, they sometimes had unexpected behavior, and sometimes were getting unexpected page speed scores and long rendering times. So when we started analyzing what's going wrong, we figured out that we have some errors, some mistakes, which are happening quite often. So we built so-called best practice analyzer. And it's nothing else than some script analyzing fragments and HTML pages for some anti-patterns. For example, defer async. If you say, in fragment my JavaScript should be loaded as defer async, page speed will say, no, I will not do anything with it. Because it cannot predict in which order your stuff should be loaded and executed. Another thing is page barrier. In page speed mode, there are so-called page barriers. It's inline script, inline JavaScripts, which are not loaded externally, but just inlined. In this case, order of execution is important, and page speed module cannot combine assets across page border. So that means if you have some fragments above page border and some fragments below page border, page speed module will unfortunately not combine anything, which will affect your page speed score again. Another thing is styles outside of head, or style sheets references with different attributes, and a couple of other things. And we build it as a script, which can be run in a development pipeline, deployment pipeline, which means if something is going wrong here, your build will just break. That's it. Of course, the whole stuff, even if it's working pretty well, the whole stuff is still work in progress, right? And not all problems are solved, and we have a couple of things which are yet have to be solved. And one of those things is authentication. What to do with pages which requires authentication, and how to serve content which should be protected for particular users. Another thing is native mobile applications. If it's possible somehow to benefit from combining parts of UI in a native mobile application, well, you cannot solve everything at once. All right, so let's come to the conclusion.
So yeah, what are the features of the UI composition solution that we built? With this solution, which we call Jigsaw internally, teams are really in full control of their services UI and do not need to rely and coordinate on others when changing it, at least if it doesn't affect others. So we have really autonomous teams. Also, fragments have a simple structure with a head, some kind of body, and script section or part. So it's relatively easy for services to provide and test their content. Page performance is not compromised in any way. On the contrary, page performance can actually be really high because of the good post optimization. Also, beyond that, Jigsaw serves as a really effective cache layer with multiple cache levels. And as Alexey just showed you, with this Jigsaw Docker solution, fragments can be tested in isolation and also in integration with other pages or fragments. Yeah, and most important thing of all, it's live and it serves thousands of requests per second flawlessly. It's live with a current German AutoScout homepage and I think the .com list page. And we're actually really happy with the solution, whereas we came from a point where we thought, wow, this is a really hard problem. We had at some point in time, we're wondering how we're going to solve this, and now we're really happy with the solution.
Let me show you one thing. Well, I hope it will work somehow. Great. Here's a result page when user. Oops, where is my mouse? When user searching for something. Well, I drive Audi A4, so I'm looking for Audi A4 usually when need to test some pages. So in this case, Audi A4, there are a couple of thousands of search results. Well, connection here at the venue is not that fast as expected, but you see I just reloaded page, it's rendered almost instantly. And what's interesting, in this page, which contains some results, we have almost 30 fragments.
So actually every item showing here in this list is a fragment.
So every item which is single car displayed on the result page is a single is a separate fragment. Yeah,
and this means that actually also every of those items can be cached at those multiple levels that we show. Yeah, and then I think that's it, and we're happy to answer any questions that you may have, and thank you for your attention.
Oops.
Oh,
it's
well.
again too fast, but anyway.
Okay.
Yeah, indeed, I have a question for Mike. So now every team builds the CSS styles on its own. So how do you avoid that these things clash?
Yeah, so so far we're just using JavaScript packages and style sheet namespaces for this. And we were afraid at a point that this would not be enough isolation. So far, it actually works fine. So, we communicate well, and actually it's also part of this best practice analyzer, which checks that you use namespaces for your service. And so far, this is actually enough. So we were afraid of this as well, because the solution provides no actual isolation. But yeah, so far we haven't run into any problems. So we had the same fear in our mind about this thing.
Part of our company culture is to give people a lot of freedom. And if you're giving good people a lot of freedom, and I hope all our guys are good guys, you figure out that people actually don't misbehave. So if you says, guys, please do it like this, and they're actually doing it like this. Of course, nobody stops guys developing homepage to call their styles, to put their styles in footer namespace, but well, it will be kind of stupid.
Yeah, and I mean, it is really interesting because this page gets combined really late. Basically, any service can mess up the entire page. I mean, we check a lot of things in this best practice analyzer in the pipeline, but still, really, teams have to rely on other teams not messing up with the page. But yeah, this gives a lot of freedom and agility to the different teams, and so far it's working very well. I mean, we had certainly small incidents, but yeah, made pretty good experiences with this model so far.
Yeah.
Do you have any kind of rules in terms of, for example, JavaScript libraries that you don't end up with like 3 versions of jQuery and Angular and React, and then if you want to upgrade also, how you handle that?
Yeah.
Yeah, the point is that user experience, well, in the past it was not that not the case, but now user experience is the most important thing for us, and rendering of whole page should be blazing fast. That means we are trying to avoid using any heavyweight libraries like jQuery. So yeah, if a team needs some functionality, they're free to use some smaller libraries, and yeah, we have just avoid using some huge frameworks like Angular, jQuery, or whatever.
That could be the same thing, that different services need like the same library,
Yeah.
and then you have different versions, and you have the library 3 times in there.
Yeah, so currently we approach this the following way. We import those libraries, or some libraries, or also, as I mentioned before, the font, as part of the page, so not as part of the fragment. So, and then the fragments that get included on that page assume those libraries and fonts to be there. Mm-hmm. So there's kind of, they rely on this. We don't know whether this is going to be the final solution to this, but this is currently how we approach this. Yeah, and thereby, yeah, the page is responsible for providing those libraries. And the good thing here is that the responsibility is pretty clear. So the team that maintains the page, or is responsible for the page, is responsible for the page performance. And thereby, if any fragment providing service messes up with a page score, or needs another version of a library or so, they have to talk to each other, and the team taking care of the page is actually taking care that everything is all right with that page.
How did you come up with all those post processors? How did you find them? I just Google it. Oh, here it is. Put it there.
Yeah, pretty much.
You know, there is a leap there between the first attempt and then you present it there, and they're there. And I was like, wow, okay.
Yeah, it's it's a good question. I mean, basically we were looking into Varnish and SSI, and yeah, we had all those problems, and then we basically went into the weekend. And then a colleague of mine, Moritz Heiber, he's from ThoughtWorks as well, just came back from the weekend and said, well, I have an idea. There is this page speed module from Google, and it can be used in Nginx. And we had ideas before to use Nginx in order to make Varnish work with ELBs, to put an Nginx in between. So we already had Nginx on the page, kind of. And then he remembered that there is this page speed module for Nginx, and that it could actually solve all our problems. But yeah, so our mood really turned from, oh wow, we're really frustrated, to, oh wow, that's a cool solution.
Great.
Well.
So this is a server-side include solutions. Any idea how you would do things like this with single-page apps, where you actually have to do all of this on the client?
That is a really good question. To be honest, we have not thought about this at all because, yeah, this is not how the AutoScout page currently works.
So I guess for now we don't have any pieces of functionality which built as a single page application. Probably it will not work if we will try, but for now we have no answer for that.
Yeah, you could try to come up with a similar approach, like having some post-processing on the client side, but yeah. Maybe you could use the same approach and adapt it to that, but yeah, we haven't looked into this at all. Think back.
Do you have automatic deployments to production?
Yeah, we actually have a completely continuous integration and delivery. So to be specific, right now every commit that is pushed goes automatically through to production if it passes all tests. So
some of the tests include the page speed.
Yeah,
Yeah,
So
indeed.
if that fails, it won't be deployed.
right.
Yeah, at least if it fails dramatically, and then of course we have monitoring, which checks the page speed as well.
So of course, if it's going from 95 to 94, of course it will be still deployed. But if it's going from 95 to, let's say, 60, yeah, build will be broken.
You mentioned that you switched to Java. Have you been a .NET shop before?
Yep.
How did that work?
Well, let's have a chat afterwards.
What is the reason then? Why?
Well,
Because, usually it goes the other way around.
No, it's probably Docker.
Yeah, I mean we basically switched, we have to say they, because I was only involved in the project at that point where it was decided that there would be the migration to Linux and JVM. So we basically went at AutoScout from C# being the main language to Scala being the main language, because I think it was agreement with the developers that they didn't want to go from C# to Java, not even Java 8. And then I think it has been quite a challenge, the migration, but at least from my point of view, developers are generally quite happy with Scala. I mean, you have to say so. But of course it's a huge migration with lots of knowledge sharing and knowledge build up needed. Yeah.
it's not like C# is a bad language or something, or .NET is a totally miserable runtime. No, of course not. Unfortunately, now it's getting better over last year or two. There was lack of automation for Windows platform. So it was possible to automate a lot of things, but since we thought about doing completely automatic continuous deployment, right? Our infrastructure is completely coded, and checked in repositories. So the zero manual intervention in provisioning services, configuring services, and all that stuff. So basically, we were not changing to Scala as a target, right? We were changing to a platform which allows us to automate all the stuff better than it was possible at that moment with Windows platform. And unfortunately, now it's, as I said, getting better and better. At this point of time, it was not possible to run .NET applications on Linux. So yeah, it was more or less obvious decision.
Yeah, I think the main strategic decision was to move to AWS, and then the decision for Linux and JVM followed from that.
Yeah, I know it's not that cool to explain all that stuff at .NET Developer Conference, right? But well, so no questions anymore. Yeah.
Why not Node.js for infrastructure?
Why not Node.js? Well,
we're using npm in the front end at all kinds of places, but yeah, we're doing server-side rendering. We use the Play framework. Oh, server-side, yeah, frameworks. Yeah, I think there was no specific decision about this. Yeah. All right. Oh.
If one of your problem was the device version of JavaScript, have you considered getting rid of JavaScript completely?
Of what?
Getting rid of JavaScript completely, like using React?
No, so far not. No. Okay. All right. Thank you very much, and have a good evening.